I joined Red Hat as of last week. I'm a director for their developer advocacy efforts. What that means is anything to do with Red Hat developer outreach. Now, whether it's, well, primarily my focus is JBoss, but you are more than welcome to talk to you about either our cloud efforts or storage efforts or virtualization effort, of course, Linux, anything. At Oracle, I was responsible for driving the Java EE 7 launch. I've been with the Java EE team pretty much from their very first release, like when we did the J2EE 1.2. So I have a lot of history, and I've authored a couple of books as well, which are O'Reilly books that you can buy them outside at a 40% discount. So Java, in general, is one of the most vibrant languages and the platform in this developer ecosystem. We talk about 9,000 developers. Java EE, which is sort of the next level, the platform has been around for about 14 years, 15 years now. Java EE 7 was literally released a few months ago. The focus has been how we can provide you best enterprise application development experience. With Java EE 6, we saw a huge adoption. That is, you can build your application to the Java EE 6 API and deploy to about 18 compliant application servers. But there were still some loopholes in Java EE 6. Folks were using a lot of other third-party libraries, and that's been one of the big focuses of the Java EE 7 platform, how to make it rich, how to make it complete, so that you can have an entire development experience within Java EE 7 itself. So Java EE 7 was released on June 12th, and the reason I quote that date is because that's the date we had a formal launch when I was part of Oracle. At that time, we did a 1 hour long keynote, 1 hour long launch event. It was an online event with about 10,000 viewers. There was a strategy part of it by the executive vice president, and there was a technical part of it. I was the MC for the show. All of that is available online, and you can watch all of that content online as well. Now, some of the formatting you may see a little messed up because the presentation was originally created in a PowerPoint on a Mac. This is OpenOffice on a Linux, and I'm not familiar with both of those. So the formatting will be a little messed up, but I'll try to cover it up as I talk through it. Now, as part of Java EE 7, there were the three big themes. The first and foremost has been embracing HTML5, how we can provide you a first-class development experience building HTML5 applications. What that means is how you can create simple WebSocket endpoints, how you can leverage the new attributes that has been introduced in HTML5 in JSF, how you can build applications that are lighter by adding standard Java API for JSON processing. So that's been sort of one of the big themes of Java EE 7. The second big theme is, which we have been doing for Java EE 5 and Java EE 6, as part of Java EE 7 is to continue developer productivity. A lot more focus on POJOs, how you can take a POJO, which is plain old Java object, add an annotation on it, define the meaning of it in the specification, and how container can take care of providing you all the services that you care about. So a lot more focus on cutting down the boilerplate code, and I'll show you some samples of that. And last but not the least, where Java EE has been very strong is about meeting your enterprise demands. And to that extent, we have added some brand new APIs to the platform. So my goal today in the presentation is to kind of go through the slides, hopefully give you enough information so that we have scratched the surface. And then when you go back, you can try out some of these by yourself. And if you are definitely looking for a lot more code, that I'm going to do tonight at the JAX London community night from 7 to 9. So in a typical David Letterman style, I'm going to say what are my top 10 features of Java EE 7. And I'm going to go with feature number 1 to begin with instead of going with feature number 10. So my first feature really is how we give you the ability to create a simple WebSocket endpoint. And I'll show you the code for that. Take a POJO, put an annotation, and boom, that is a WebSocket endpoint. We have added the ability to build first-class batch applications. So no longer you have to rely upon third-party proprietary frameworks. All that capability is part of the platform now. We have also added, as I said, a standard API for JSON processing, so you can generate and parse JSON accordingly. Fourth new functionality to the Java EE 7 platform is where we have added the capability you can spin new threads. Well, you can do that earlier also, but now when you spin up new threads, these threads have your right context. Security context, GIND context, class loading context, all of that context is passed on to these threads. Most importantly, these threads are now managed by your server. These are not user threads. Java is a managed environment, and that's sort of the big difference over here. So the first 4 features that I talked about, the focus is like all of those are brand new functionality which have not existed in the platform up until now. Then we simplified JMS. The last revision of JMS was literally 2003, about 10 years ago. There was no generics, no annotation, no dependency injection in the platform at that point of time. All those concepts were completely foreign. Nobody has heard of those concepts at that point of time. So the focus of JMS has been to simply catch up with the platform, and that's the name, simplified. This is what it indicates. We've also introduced the concept of how you can do container managed transactions outside an EJB, and we'll talk about that briefly. JAX-RS has shown great review and feedback as part of Java EE 6, but was primarily server-centric. Now we added a client-side API to that, and I'll show you some samples around that too. To provide a simpler and a more seamless out-of-the-box experience, we have also added certain default resources. If you're building a Java EE application, most likely, actually in all possible cases, you're likely dealing with a database. If you're dealing with a database, why do you have to create a database resource? So let's provide a default database resource. And there are other resources we are providing. The idea is to lower the bar for jumping into Java EE 7 bandwagon. More annotated POJOs, and as part of JavaServer Faces, we added the concept of faces flow. So now I'm going to go through different specifications and then dig into more details for each one of those. So let's look at, first of all, Java API for WebSocket. What does it give me? Now, HTTP has served good need for us so far. However, there are several issues, well, at least 3 issues with HTTP. First, it is client initiated. So client sends a request, server processes it, and responds back. So it's always client initiated. If server wants to send some data to the client, out of luck. Well, not really out of luck, but there are no standards for it. There are hacks like Comet, reverse AJAX, or server push. Things like that are available. And they're very server dependent, programming model dependent. And you have to kind of fine tune your application, whether I'm doing polling, long polling, what am I doing really, and is it really tuned for my application? So that's one problem. The second problem with HTTP is it's very chatty. If you want to do a simple hello world, you have to send a whole bunch of data from the client to the server, and the server sends it back to you, a lot of other data. That's primarily in terms of the HTTP headers. And if you're doing a few connections per second, or few requests per second, it's okay. But the moment you get into a few hundred requests per second, few thousand requests per second, it doesn't scale very well. And the third problem, which is the biggest problem, is for each HTTP connection, there is a new TCP connection that is initiated for you by your networking stack, or by your browser, or whatever your operating system is. And that's again a scalability issue. And that's exactly where WebSocket fits in. So it's non-chatty, it's not single direction, and it does not require multiple TCP connection. So what is WebSocket? WebSocket is defined using RFC 6445. Just Google for that number, you'll get that text document, download it, and you can read what does it do. 6445 is the number. Essentially, our WebSocket is a bidirectional. That means client can talk to server, and server can talk to client. So it's bidirectional. It's full duplex. Full duplex means client and server can send messages to each other independent of each other. There is no request-response design pattern over there. They can send messages to each other independent of each other. And the best part about WebSocket being is over a single TCP connection. Once you have established a TCP connection, your HTTP connection is running on that, you can upgrade an HTTP connection and make it, or upgrade to a WebSocket connection. I have a talk later today where I talk a lot more detail about WebSocket, so feel free to attend that. But once the connection is upgraded, on a single TCP connection, the client and server can talk to each other endlessly until and unless one of the parties explicitly close the connection or say, you know what, I don't want to talk anymore. Now, how do we support that programming model? I mean, it's good to know all these details, but you don't need to know all these details. So on the bottom right here, what you see is a simple POJO. So I can say public class chat server. On this, I put annotation called a server endpoint. I make it as a chat endpoint, and I say whenever you receive a message, call this business method called as chat, and this is indicated by @onMessage. So that's what we call as an annotated endpoint. By literally putting an annotation, I can just mark POJO to be a WebSocket endpoint. Similarly, I can have a programmatic endpoint. So you know what? I want a little bit more control over how my WebSocket endpoint is going to look like. So I can actually have a programmatic endpoint by implementing an interface. So you have a lot more control on how the connection handshake is happening, whether it's a single instance of WebSocket that is serving all the clients and things like that. So a lot more variations are possible, and I'll cover them in my later talk. Just like @onMessage, which is where a business method is being invoked whenever a message is being called, there are other lifecycle methods of WebSockets, such as WebSocket open, WebSocket close, WebSocket error. And those are corresponding annotations like @onClose, @onOpen, so on and so forth. So those annotations are available. You tag your methods with those annotations, and those methods are being called whenever that lifecycle event occurs. And of course, in terms of the packaging and deployment, there is nothing new defined over there. They go bundle as part of your regular WAR file, and they get deployed as part of it. So literally a single POJO, no deployment descriptor, and all of that. And I'll show a lot more code around this in my talk at 7 o'clock, which is from 7 to 9 as part of JAX London Community Night. So a little bit more detail here, for example. Here I have my chat bean. I'm saying a server endpoint, mark it as this is a URI where my WebSocket endpoint is listening. These are my lifecycle callback handlers. All I'm saying is, you know what? Anytime a connection is open from the client, this is being the client, add it to a set of session. If a connection is closed, remove it from the session. So at the end of this method, basically, at any point of time, I have the list of open connections for me. Now I can add a simple method called as message, and in that message, I have just @onMessage. Every time I send a client sends me a request, this method is basically where my payload is available. I get the payload, I iterate over the list of existing connected clients, and I broadcast a message to them. So literally, in a few lines of code, you have written a fully functional chat server. And the code is readable. Fortunately, you don't have to comment it because it's more like English. All right, the next API that I'm going to talk about is Java API for JSON processing. As in a standard Java process, as in a standard JCP or Java community process, each JSR, each technology is created using a Java specification request. And each Java specification request, or JSR, is assigned a number. So Java API for WebSocket was JSR 356, and this particular one is JSR 353. Now, in terms of Java API for JSON processing, I want to go back to the analogy of what we have existing already in terms of the XML land. So in terms of XML, if you take a look at it, there is Java API for XML processing and Java API for XML binding. In terms of processing, it's a low-level API where you can read from a stream, you can receive the events, you can manipulate the reader, etc. In terms of XML binding, you take a POJO, you put an annotation in it, you know what? You go convert it into XML and vice versa. You do whatever your conventions are and deal with it. So those are the two APIs in XML land. The Java API for JSON processing is more like JAX-P. The Java API for JSON binding, which is more like JAX-B, is going to be coming in the next edition, hopefully. And even in Java API for JSON processing, just like JAX-P, I have a streaming API and an object model API. So streaming API, in that sense, really gives me an ability to look for particular events from a JSON structure. Now, if you think about a JSON structure, it's essentially a bunch of name-value pairs. So the events could be, key, value, what kind of value it is. Value could be an array. Is it a string or is it a string? Is it an integer? Is it an array? Is it an array element? So those are the events that are being generated. So the approach, whether you want to deal with streaming API or object model API, it truly depends upon, do you want to read the entire JSON structure in the memory and play with it, or the JSON structure is big and you only care about a certain key, then you do the streaming approach, where you say, you know what, I'm looking for this event. If the event occurs, like say key event occurs, then give me the key value, and then I'll compare it, and then I will do whatever parsing I want to do. So you can do mix and match of those. So here, for example, look at my JSON structure. This is an anonymous JSON structure. Says first name is John, last name is Smith, age is 25, phone number is an array with a couple of name value pairs in each of the elements over there. Now once I create a JSON parser, then I can say, give me the next event from the parser. This is the very first event is really start of object, which is right here. Then I say parser.next, then it comes over here. Then I say parser.next, it comes right here. And at that point of time, when I say give me the value or get me the string, you get the value, which is John. So you can see how it is naturally skipping across the elements without reading their value. On the other hand, if you're doing object model, it would read the entire thing into the memory, and then you can index into, you know what, give me this object, give me this element of the array, everything is available to you. The third new API that we added to the Java E7 platform is batch applications. Now, if you're familiar with Spring Batch, a lot of this has been taken from Spring Batch, because that's where really innovation has happened. Now it's time to make it a standard. Now, what is batch applications good for? Typically for, which are compute intensive or disk intensive tasks, which typically require processing thousands of records or millions of records, which you may not want to do during your peak traffic time. So for example, let's say Monday 11 o'clock in the morning, there is no point processing your payroll for your entire company at that point of time. You probably want to take care of your customer needs first. A good time to process your payroll is maybe Saturday midnight or Sunday morning 2 a.m. So things like that. Now, if you're processing a payroll, you're typically processing, depending upon your company size, maybe a few hundred records, a few thousand records. Now, if you're processing a few thousand records, what you may want to do is you will read a record, you will validate a record, say if the employee still exists. Yes, it exists, and I need to pay a salary, I need to pay additional bonus, I need to pay whatever additional money, and then you say, okay, go ahead, submit to the account. Now, for each read and each process, you may not want to write to the database. That's not a very efficient operation, specifically if you're doing thousands of records. So what you do is you read, you process, and you aggregate for writing. Read, process, aggregate, read, process, aggregate. And once you have reached a certain number of aggregation or chunk items, then you say, now go ahead, write it to the database or whatever it is. That whole design pattern is called as chunk processing style in terms of batch. So what you're doing is you have a chunk size defined, chunk size being say 100. That means you're reading 100 records, reading a record, processing a record, aggregating it. Once the aggregation number reaches 100, that means you're going to write it to the database. That's a lot more efficient, because certain times you may not even be, you may even say processing is returning an invalid record. That means nothing needs to be written into the database in that case. So the chunk style that I talked about is more like item-oriented processing. On the other hand, you also have a task-oriented processing, which is what we call as batchlet. This could be like just execute a task. Could be upload a file, send an email, or something like that. The primary processing style is definitely recommended to be the chunk processing style. So let's see how that works. Well, first of all, in my WAR file, I have something called as a job operator, a job XML. That's how I define my job, what a job is going to look like. Each job essentially consists of a step. A step is sort of the logical representation of the job. And as I said, chunk processing style is a primary processing style. You have a a reader, a processor, and a writer for you. Okay? Now, each job can be picked up by a job operator. Job operator will pick up a job from the job repository, which is where all your jobs are stored. So essentially, your job XMLs are all stored in job repository. Job operator picks up a job, which has a step, and it fires the job. And then the batch runtime knows as part of the job XML, oh, this is the reader, this is the processor, this is the writer, and it's going to execute it. A little bit more detail for that. Now, this is how I define my job, for example. I have a logical step, which has an ID. In the step, this is of the type chunk. I'm defining my item count. They're saying basically do 3 items at a time. This is my reader, this is my processor, and this is my writer. Okay? How does my reader look like? Well, it's just a Peugeot implements item reader, and I have a method called as read item. It also has a method called as open, where I'm likely initializing my stream, where I want to read the records from. So think about if you want to process a CSV file, and like say you are a sales firm, you get sales data from all different of your stores in a CSV format. End of the day, you get all the CSV files, and you want to merge it, and you want to write it to the database. So you have potentially thousands of records that you want to read, process, and write to a database. So in that case, you will have an open method in your item reader where you will read a file. Read item will just dump read it. Just dump read it. There's no processing in there. The item processor is where the processing or the validation of the record is going to happen. Oh, I got a data, and is it valid data or invalid data? If it's invalid, return null. That means nothing to be aggregated. If it is valid, then return an item which gets aggregated in my item writer. And once you have the item writer, if you see, the parameter over here is of the type list. And if it's a list type, that means you're aggregating your data that needs to be written out. Now here, I could be using Java Persistence API to write to a database. I could be using Java Mail to send an email or whatever I want to do. And once again, you have an open method here where you open your stream. The fourth new API that we added to the Java EE7 platform is concurrency utilities. And as I was saying, in Java EE, it's not recommended to create your application threads. The servers don't restrict it, but it's not recommended because you can't have your class loading, JIND, security, all those contexts be available to those user threads. There is no way to pass that context explicitly. But now with concurrency utilities, just like you have executor service, schedule executor service, you have managed version of those in Java EE. So you can have a managed executor service. So all your design patterns that are available in Java SE are also available in Java EE now. So you could say, hey, I want to just start a managed executor service. Let it spin up some threads for me. I'm going to do something in my threads. And by the way, when I'm in those threads, I have the entire JIND, security, class loading context with me. So it feels like as if I'm being part of the application server itself. The one context that is not being passed over is the transaction context, because coordinating transactions across multiple threads is not an easy task. So that is explicitly not being passed. All other contexts are available. So here, for example, I can say in my servlet, I'm just injecting a managed executor service. Then I can say to the executor, my standard Java SE principle, I submit a new task. Task is implementing runnable. And in the run method, I have my business logic. This could be runnable. This could also be callable. And there are subtle differences when you use runnable and callable. That's not to be highlighted here. So that's sort of the new changes that have been incorporated into the Java EE7 platform so far. Let's take a look at Java message service. What are the key changes we made in the platform over there? And I think this is better explained instead of, talk is cheap, show the code. This is how you send a message using JMS 1.1. And don't try to read the code. I don't expect you to read it. But let me highlight the issues with the code here. First of all, at the very top, you're creating application server specific resources in the sense that you are telling that, hey, this is my connection factory, this is my destination. All of those need to be manually created or as part of your deployment script. Second, you're writing a whole lot of boilerplate code. And that boilerplate code is because that's how the API was written. This was written in 2003. That's the amount of knowledge we had. That's the exposure we had of the Java platform. That's what we did our best. And finally, a lot of exception handling. Everything is a checked exception. If I'm closing the connection, even that is a checked exception. So I've got to handle that. And by the way, if I'm trying to close the connection and if a checked exception is thrown, what do? Well, I wrap it into a runtime and I throw it. So why not keep the programming model simple? So that's sort of the focus for JMS 2.0. All of these problems were specifically addressed. We are making heavy use of runtime exceptions, keeping the code simple. If you want to catch it, your problem. If you want to let it propagate, let it go. Let the runtime handle it. Boilerplate code has been completely cut down. The application server specific resources are again cut down. There are defaults for that. There is a default connection factory that you can use. So if you don't specify a connection factory, it automatically connects to that. You can still specify your specific connection factory. There are ways by which you can create destination as part of your deployment. So you can just put the annotation in there, and it will automatically create those destinations for you. So let's take a look at the updated code. And that's my updated code. Once again, this was sort of my JMS 1.1 code, and this is the new code. So really simple. First of all, JMS context is the new entry point to my JMS simplified API. I'm just injecting a JMS context, and I'm not even specify my connection factory here because the default connection factory kicks in automatically. Then I'm injecting my destination, and here again, even though I'm specifying a destination name, but this destination name could be created using JMS destination definition annotation, literally as part of your deployment. And the best part is how I'm sending the message. All that boilerplate code that I talked about, exception handling, is gone. I'm saying context, which is my entry point. From that, create a producer, and then send a message. What is the message? And the destination. Now, if I'm a developer, or if you are a developer, if you're inheriting this code without any comments, and you're inheriting this code without any comments, which would make you more happy? Well, I would be scared to inherit this code, because I would need a lot of comments just to understand it. And frankly, to me, if you are adding comments to your code, there's a problem with your code. You're not writing good code. The code should be simple, readable. It should have a good level of abstraction. And that's exactly what it is over here. This code is like English. I can read the code. I don't need to write comments. If I'm inheriting it to somebody, if I'm giving it to somebody, they won't be scared of me. Like, oh, I don't want to inherit this code. Yeah, I would love to take this code. This is easy to maintain. So it really improves the semantic readability of your code. As I said, some of the formatting is kind of messed up. My bullets are all over the place. There are no bullets in this one. In Java API for RESTful web services, the version 1.1 or 1.0 and 1.1, the focus really was on server-centric. It was only server-side. You could take a POJO, put an annotation, publish it as a REST endpoint. All the standard HTTP verbs were supported. All that was goodness. Now with JAX-RS 2.0, our focus has been to make it a lot more richer. So the first thing we added was JAX-RS Client API, a standard API to invoke a REST endpoint. And I'll show you a sample for that. We also added some extension hooks, such as message filters and entity interceptors. For example, I want to deal with logging my HTTP headers. So you can put your message filters over there. And I want to deal with my body of the HTTP request. That's when you put entity interceptors. And the reason we put filters and interceptors as two separate ones is because when you're processing the body, it may require invoking a business logic. It may require binding. It may require talking to a database. Most of the time, you may be OK with just looking at the HTTP headers. It's a REST request after all. So if you're OK with looking at the REST headers or the HTTP headers, use filters. If you want to process the body, then use the entity interceptors. So typical example is you can look at the headers using message filters, take a look at the content type, and if it says, oh, by the way, the content is gzipped, then dynamically inject your entity interceptor, which will automatically ungzip the content for you. Or if you want to gzip it, you can gzip it as well. So that's sort of the use case for filters and entity interceptors. Another new feature in JAX-RS 2.0 is we don't like to be greedy, so we want to be sharing. Think about the use case where you're on a server side, you get a request, you know the request is going to take a few seconds. I'm talking to an old clunky database, or I'm invoking some random web service, which I don't know what the SLA for that web service is. So in that case, you want to make sure, hey, I'm not going to hold on to the thread on the server side. Let somebody else kind of share the thread with me. And if I have the response ready, I'm going to respond back. So it's very typical suspend and resume design pattern. But the idea is you are explicitly marking your server side to be asynchronous. Now the client is still synchronous in that case. Client still holds the connection. But on the server side, your thread is freed up. And the way it works is, you on the server side, since you marked it to be asynchronous, the thread is freed up. You spin a new thread to do the job. When the job is completed, it tells the server, job is completed, return the response back to the client. Client is still asynchronous. If you want to be more sharing, then you can make your client also as asynchronous, in which case is actually using the JDK future object to receive the response or process the response. Client and server asynchrony are completely independent of each other, but you can use them both together at a given point of time. So this is a sample of how my client API looks like. I can just say client builder, create a new client. This is sort of my entry point to the client API. Then I can say I'm targeting it to a specific URI. In the URI, I can specify what is the variable part of my URI. I can resolve the template, basically mapping this value to a specific value. Then I can add query parameters, build a request, and fire a HTTP GET. And then I'm saying I want a response back as a string. I could specify a POJO. I could do all the content negotiation. All of that can be done here. A lot more details at the JAX London community night. All right. CDI, context and dependency injection, was added in the Java EE 6 version. And it was such a fundamental change to the platform. It got a lot of good feedback. And it was such a fundamental change, once again, that we decided that, hey, let's make it enabled by default. In Java EE 6, you had to add a beans.xml in order to enable CDI. In Java EE 7, you don't need a beans.xml. If you don't have a beans.xml, there is a default enablement of CDI for a Java EE 7 archive. I mean, of course, there are rules around that which of the APIs which of the beans are available for injection and things like that. Now, if you do have a beans.xml, then which of the beans are injected, there is a little bit more finer control over that now. For example, there is a new attribute added called as bean discovery mode. A value for that is all. That means take all the beans and make them available for injection. Anything in the var is available for injection. You can also say annotated is the bean discovery mode value, in which case only the beans which are annotated with CDI annotations are available for injection. And if you don't have a beans.xml, that is the default. And finally, you have one knob to turn off injection completely. You can say, I don't want anything in this bean to be available for injection. You can change the value of bean discovery mode to none. So completely disable injection in that bean, in that archive. So those are the different mechanisms by which you can control what gets injected or does not get injected. Another new annotation added to CDI is vetoed, where you can explicitly mark a bean to be not available for injection at all. That means this is vetoed out. You cannot do anything about it. Bean validation, once again, a specification that was added in the Java EE 6 version of the platform. The idea was you could specify a constraint on a bean, and then the constraints on the bean would be honored at the runtime. runtime like JSF. So for example, you have a backing bean. On that backing bean, you specify the constraints such as at size. Say you have on a POJO, you have a string field. On that, you say at size max equals 10. That means I don't want that string field to be more than 10 characters long. All right. So if a JSF, you have a JSF form with the backing bean with that bean validation constraint. If you enter 11 characters, you click submit. It will throw a constraint violation exception, not accepted. So it won't do it. The biggest benefit of that is declarative. Once again, improving the semantic readability of your code. You don't have to do client-side validation. If you can do it if you want to, but the idea is by specifying just that one annotation, there is a capability available in the platform. You are just leveraging it and making your life simpler. Now with bean validation 1.1, we have made it a little bit more elaborate. You can specify that validation constraint on any POJO. So if you are invoking a business method, on the business method, you can put the validation constraint on any of the method. So instead of going in your method and saying if value is not equal null, return whatever exception or do something, you can literally put the exception, add the constraint right in the method parameter along with the method parameter. You can even put a constraint on the entire method, which is then honored by the return type. For example, you can put at future. I think I have a sample for that. There you go. So here, for example, I have place order. I'm saying, OK, I don't want the product name to be null, so you just put at not null. I don't have to say if product name not equal null and things like that. Here I'm saying at max 10. So that means is integer, and it cannot be more than 10. And then you can also put your custom constraints as well. So I can say string customer, and at customer is my own custom defined constraint annotation. And finally, when I put at future, the idea is a return type. You're getting an appointment date. It better be in the future. So if the date is not in the future, it's like as if your method is never being called. It's going to throw a constraint violation exception. So this is what we call as programming by contract. Your contract is this is what needs to happen. This is how the contract should look like. If the pre and the post conditions are not honored, it's as if the method is never being called. It instead throws a constraint violation exception for you. JPA has been one of the oldest specifications in the Java EE platform. In JPA 2.1, we made slight tweaks. One of the big additions that we have done over there is how you can generate schema from your entities or even from SQL scripts. So today, we can take a database table and generate JPA entities from that. Standard mapping is available. But there is no standard mapping which says take a JPA entity and map it to a table. So with schema generation properties introduced in JPA 2.1, you can do that now. So for example, in your persistence.xml, you can specify JavaX persistence schema generation properties and say, take a look at my metadata, which is basically my entity, and generate tables from that. So you are an expert JPA developer. You know exactly how to code your entity. You put your embedded types. You put your relationships, everything in JPA. And now you generate your database tables from that. Or you can also say, hey, here is my SQL. Take this SQL and generate tables from that. So both the mechanisms are possible now. Or you can also say, take my JPA entities. Do not generate a table, just generate my SQL scripts. So all sorts of combinations are possible, thereby generating a little bit more love between your DBA and your typical IT administrator kind of person, which typically don't see eye to eye each other. No, I'm a programmer. No, I'm a DBA. So how do we work with each other? Hopefully this will bridge the gap. Something else that we have added as part of JPA 2.1 is what we call as unsynchronized persistence context. This is very relevant specifically in a mobile world. By default, if you are working with a persistence context, anything you save to a persistence context and the moment you commit the transaction is automatically persisted to the data store. With the unsynchronized persistence context, let's say you're in an offline mode and you're not connected to the data store. So what happens? Well, in an unsynchronized persistence context, that is possible. In a synchronized case, that is not even possible. So here, you're playing around with the persistence context. You need to explicitly join a transaction, and that's when you commit to the database. Now, of course, you could have the read-write problem and stale problem and things like that, but you need to be aware of that sort of, and that's where your locking mechanisms come in handy. We are also adding ability to call user-defined functions from a database and also the stored procedures. In Servlet, we have had this do get and do post methods forever. But if you want to read in a do get method, it's done in a blocking way. Once again, we don't want to be greedy, we want to be sharing. So that's what I teach my kids, but that's the tone comes out. But the idea here is, if you are reading from a stream and the stream somehow has not been closed from the client side, then you are stuck. You're really waiting for a timeout. And what if you're getting intermittent data and you don't know when the data is going to finish? So your thread is again stuck reading on the server side. So how do we solve that problem? Once again, a very standard suspend and resume pattern. The idea is, well, I think I have a code for that. So this is how you do the read right now. This is my do get method. I'm blocked here reading for it till I get a -1. This -1 could be for multiple reasons, either connection closed, timeout, whatever. Now, in terms of non-blocking I/O that I'm talking about, how we share, we set up a read listener. In an asynchronous servlet, we set up a read listener or a write listener, whatever we want to do. In the read listener, I have a method called as onDataAvailable, which is automatically being invoked every time data is available. So, in an asynchronous servlet, you have set up the read listener, data comes available, it calls that onDataAvailable, you read the data, you process it, you can read as much data is available. Once it's done, it goes back, the thread is returned back. It becomes a passive thread once again. So nothing highly innovative here, but a very typical suspend and resume design pattern allows you to more sharing. Now, as I talked about, the way WebSockets are implemented by upgrading an existing HTTP protocol. So in Servlet 3.1, we added a standard mechanism by which you can upgrade an existing HTTP connection. And the way we are leveraging that in WebSocket is by providing a standard WebSocket protocol handler or a protocol upgrader effectively. We've also done some security enhancements. Let me see if I have a source code for that. Oh, mine. What are they? So think about a web XML. In a web XML, let's say you are not exposing any method, get, put, post, delete, none of those methods, which is good. If you're not doing anything, then all the methods are secured. None of the methods can be called. But the problem is, if you are exposing one method, say HTTP GET, and you put a security realm around it, yes, that method is secured by all other methods, then become automatically unsecured. That's a security threat. That means anybody can call post. So you have to explicitly disable it and things like that. Now, with Servlet 3.1, we have added a new element called as deny uncovered HTTP methods. So if your one method is exposed and all your methods are uncovered or basically unexposed, actually exposed, then in your web XML, you can add an element called as deny uncovered HTTP methods. That means it will basically disable invoking all of your methods. They need to be explicitly covered in a security realm before they can be called. Now, if I can take a quick break, I'm not sure if I have internet connectivity here, but let's try it. Oh, seems like we do have internet connectivity here. Okay, so this is a GitHub workspace. I have about 165 plus samples here. These are all focused on different Java EE 7 technologies. It's github.com/Arun-Gupta/Java EE 7-samples. So I have about 165 plus samples over here that I built over the past 6 to 9 months. These are all brand new samples showing all the technologies that I talked about. So for example, if I want to look at what WebSocket samples are available. So I click on WebSocket here, and you can see there are about 30 plus samples exclusively on WebSocket. If you want to look at the JAX-RS samples, so you click on JAX-RS, and there are again 25 plus samples just on JAX-RS. If you want to look at the batch samples, so click on batch, and it shows you the different concepts of batch. Again, about 12 to 15 samples over there. So there are about 165 samples that you can look at. The one that I added recently, for example, you can go to extra NoSQL, and Cassandra, Couchbase, HBase, Mongo, Neo4j. So all of those different NoSQL databases, how they would operate with Java EE applications, I've added those samples over there. By all means, this is on GitHub. Fork it, tag it, send a pull request. If you see, Arun, I would really like to see a sample on this, file an issue on this. If a sample is not working, file an issue on it. I have all of these samples working on GlassFish anyway, and now that I'm part of Red Hat, I've been trying to get them working on Wildfly, and I've been filing bugs as and when I find that these samples are not working on Wildfly. Let's talk about JavaServer Faces. Now, JavaServer Faces, again, it's been a mature technology, been there for a while. With JSF 2.2, we added a few big ticket items over there. Faces Flow is one of the big ticket items that we added. The idea behind Faces Flow is, typically, if you are in a web application, you have a set of pages that are working with each other. So think of it as a shopping cart. You have a shopping cart, then you have a credit card detail, a postal address, and some other details, 4 or 5 pages that typically work with each other, and they have a corresponding backing bean as well. If you want to put that together as a module, there are no mechanisms that says in JSF how these are going to work together. You have to create your own mechanism. If you want to package it as a module and ship it to somebody else so that they can leverage this functionality, that's not possible. But with JSF 2.2, we created a mechanism by which you can package it all together as a jar file and share it with others. Again, sharing is important here. So that's the Faces Flow feature. Now with JSF 2.0, we got away from using JSP as sort of the templating language. I know somebody who has an entire website as a single JSP. Why? Because it's possible. It's a JSP. I can put my Java code, I can put my database code, I can put everything in my JSP. It's easy to maintain. I can look at the whole thing at one point of time. So don't be surprised. There are people who think that way. But that was like many, many years back. With JSF 2.0, the big change we did was we said JSP is not the recommended templating language. If you want to do a MVC, true MVC, your views should be written in XHTML and CSS. And your model and controller should be sitting in the backing beans. Model typically is a JP entity. Controller is either servlet or a EJB or a CDI bean. So that was a great step by JSF 2.0. With JSF 2.2, we took that to a next level. We said, all right, you can have a custom look and feel, you can have composite components, all that goodness as part of JSF 2.0, but let's see now how I can create a custom look and feel which is also pluggable. So once again, the way with Faces Flow, we can take the entire pages and beans together in a jar file and ship it across. With resource library contracts, I can create contracts, which is basically custom look and feel. I can create contracts as a jar file, and then again ship it across different libraries, or ship it across different WAR files, and say, you know what, I'm referring to that contract in the jar file. So no longer you have to worry about how the contract or how the look and feel is defined. You just refer to a contract, and it automatically renders the look and feel in your WAR file. Once again, in the community night, I'm going to show lots of samples on that nature. We added a new file upload component, and we also added support for some HTML5 friendly markup. This is where I was talking about how we added support for container managed transactions outside EJB. Up until Java EE 6, if you want to do user managed transactions, yeah, you can do that anywhere you like. If you want to do container managed transactions, you were restricted to EJBs. Now, you want container to manage a transaction, do an EJB. EJB has a bad reputation primarily because of history. We try to change that a lot as part of Java EE 6, but folks who are still living in the J2 EE 1.3, 1.4 land, they don't like EJBs. So another thing that we are doing as part of Java EE 7 is giving you container managed transaction on a POJO object. So on a POJO, you can put an annotation called as add transactional. Then every method in that POJO becomes transactional. You can take a POJO, you can put a transactional annotation on a method, then only that method becomes transactional. So it's just like very Spring-like semantics, a lot more powerful. We have also added a new scope called as transaction scope, which ties the life cycle of a bean to a transaction. If the transaction is active, the bean is active, and if the transaction is if not active, the bean is passivated. This is what I call as a pancake diagram for Java EE 7. You can see the 4 new specifications that have been added: batch, concurrency, JSON, and WebSocket. Whoa, this was an animation glitch from upside down. This was an animation glitch from PowerPoint on a Mac to OpenOffice on a Linux. But the idea was, let's see if the idea still exists. OK, no, the idea doesn't exist. Oh, this is what the idea was. Funny. I don't know why it behaved that way. But on the bottom, what you see is your sort of a typical 3-tier architecture. So you have your bottom tier, middle tier, and your top tier. That's how I see them kind of split up. Oh, OK. So GlassFish is the reference implementation for Java EE 7. So all the functionality is available there. You can download that from glassfish.org. Or of course, now I'm part of Red Hat. So all of these functionality are getting built into JBoss as well. So JBoss community is huge, big. One of the deliverables of the JBoss community is JBoss application server. Now, earlier this year, we changed the name of the JBoss application server to Wildfly. So Wildfly is sort of the application server deliverable from the JBoss community. And that was a vote, again, given by the community. The voice was raised by the community because the JBoss application server is such a big thing. Let's give it its own identity. So that's what the Wildfly thing is. Wildfly 8 is what we are working on right now. And Wildfly 8 beta 1 is already available. The GitHub samples that I showed you, I have personally tried lots of samples over there. And several of them work, but some of them still have some glitches. And I'm following up with the engineering team on that. But in the meanwhile, you can definitely download Wildfly 8 beta 1 and try it out for Java EE 7 compliance. Now remember, this is still beta 1. So if you have any feedback, we more than encourage to take that feedback. Late last year, we started this concept of participating in Adapter JSR. How many of you are a member of London Java community here? OK, so you're probably familiar with Adapter JSR. If you are not a member of London Java community, guys, you are Londoners. You should participate in a local Java user group. That is so imperative. That's where the cool stuff happens. Now, London Java community started this Adapter JSR effort a couple of years ago. And as one of the big Java guys, last year, I started working with Martin and rest of the gang on how we can leverage that for Java EE 7. And the thought process over there was, because all the specs are new, a lot of work is happening, so these different Java user groups, they started helping us evolve the spec. What does that mean? Well, they started downloading the spec, they started reading the Java doc, they started building applications around it, they gave us feedback, they tried the implementation, extensive feedback. And there were like about 19 jugs, literally from all around the world. So you can see there are jugs from South America, North America, Africa, Asia, all over the world, Europe, all over the world that were participating and giving us feedback. To the extent, there was a sample that was built by Belgium Jug that was included in the Java EE 7 SDK. So yes, you can do it. Now we're going to start something like that for Wildfly 8, and we would love to hear your feedback. And that's it. Questions? All right, thank you.